Imagine a car is at rest initially. So the distance traveled and the time would obviously be what? 0. Now imagine the car is moving continuously. Now let us consider the distance traveled by this car is 0.5 km for 1 minute. From this we can calculate the speed of the car by using the simple formula, that is speed is equal to distance by time, and we get an average speed of 30 kilometers per hour. Now imagine there was a speed breaker in the road with this 1 minute of travel. Automatically the car will decelerate or deaccelerate, and the speed of the car reduces below these 30 kilometers per hour, right? Again, if we accelerate the car gets increase in speed and it goes above 30 kilometers per hour. From this we observe that throughout our travel the speed is not a constant and it is differentiable. We can notice that within this time travel, that is from 0 to 1 minute, the speed of the car would be at this average speed of 30 km per hour for at least once or twice while accelerating and deaccelerating. Now let us see this concept as Rolle's theorem. Let f be the function map from the closed interval ab to the set of real numbers r, and let f be continuous in the closed interval ab and differentiable on the open interval ab, such that if f of a is equal to f of b, then there exists some c in ab such that f dash c is equal to 0. Let us analyze this corresponding theorem through a graph. So I have a graph over here. Let y is equal to fx be a curve, and a and b are 2 points on the curve at which the function f of a is equal to the function f of b. The slope of the tangent at any point on the curve of f of x is represented by the derivative of f of x, that is nothing but f dash x. We can notice that the slope of the tangent becomes 0 at least one point between AB, that is at point C, and its function is what? F of C. The derivative of the function C is 0, so the slope of the tangent is what? Horizontal. Rolle's theorem also states that the value of the continuous function will be equal to another point only when the curve goes up and down and then comes back to the same point. At the highest and lowest point in the function, the slope of the tangent is horizontal, that is its derivative, and this function will be 0. Now to verify Rolle's theorem for the function, that is f of x is equal to x square plus 2x minus 8, where x is an element of minus 4, 2. To verify Rolle's theorem, we need to satisfy these three conditions, that is f of x is continuous on closed interval minus 4, 2, f of x is differentiable in open interval minus 4, 2, and f of minus 4 should be equal to f of 2. If all three conditions are satisfied, then f dash c should be equal to 0. So f of x is equal to x square plus 2x minus 8 is a polynomial function. Polynomial functions are what? Continuous functions. So you can say this is continuous in the closed interval minus 4, 2. And also you can see that this, since it is a polynomial function, it should be differentiable in the open interval negative 4, 2. Now checking for the third condition, that is f of minus 4 is equal to f of 2, we can see that f of x is equal to x square plus 2x minus 8. So when I put f of minus 4, I get it as minus 4 square plus 2 into minus 4 minus 8. So substituting all the values, you get the final answer, that is 16 minus 8 minus 8, or that is equal to 0. To find f of 2, substitute x is equal to 2 and you get f of 2 is equal to 2 square plus 2 into 2 minus 8, that is 4 plus 4 minus 8, and we get it as how much? 0. Now according to the theorem, f dash c is equal to 0 for some values within minus 4, 2. And from this we can see that f of c is equal to c square plus 2c minus 8, or we get f dash c is equal to 2c plus 2, and from this if I equate it with respect to 0, I get c is equal to minus 1, which belongs to minus 4, 2. Thus our Rolle's theorem is now satisfied. So we looked at all the three conditions, we found out the value of c, and that c is now belonging to the particular interval, that is minus 4, 2. Now verifying Rolle's theorem for the function y is equal to x cube plus 4 for a is equal to minus 2 and b is equal to 2. So that is the interval. So look at the interval, it is minus 2 to 2. To verify Rolle's theorem, we need to satisfy the three conditions we discussed earlier. That is, fx is continuous on closed interval minus 2, 2, fx is differentiable in open interval minus 2, 2, and f of minus 2 should be equal to 2. If all these three conditions are satisfied, f dash c should be equal to 0. And the given function, take f of x is equal to x cube plus 4. Again, another polynomial function, and this should be continuous in the closed interval -2, 2, and also it should be differentiable in the open interval -2, 2. So here you can see that f of -2 should be equal to f of 2. So when I find that from the function f of x is equal to x cube plus 4, I get f of -2 as -2 cube plus 4, that is -4, and f of 2 as 2 cube plus 4, that is 8 plus 4, that is 12. So directly from this you can see that f of -2 is not equal to f of 2. So will our Rolle's theorem be satisfied here? No, because the third condition is not satisfied, that is f of a is not equal to f of b. So since that condition is not satisfied, you cannot apply Rolle's theorem and you cannot find c using the condition f dash c is equal to 0 also. Mean value theorem. Let f be a function map from the closed interval ab to real numbers, to the set of all real numbers. And let f be a continuous function on the closed interval ab, and also f of x be another differentiable function on the open interval ab. And c an element of what? ab, such that f dash c is equal to f of b minus f of a divided by what? b minus a. So these are the conditions for mean value theorem. So what is different here from Rolle's theorem? Rolle's theorem f dash c is equal to 0, but here f dash c is equal to f of b minus f of a by b minus a. Since f dash c is the slope of the tangent to the curve y is equal to f of x at the point c, fc, according to the mean value theorem, there is a point c between a and b such that the slope of the line at that point a, f of a and b, f of b is the same as what? The tangent at c, f of c. To simply say, there is a point c in AB such that the tangent at that point CFC is parallel to the secant between AFA and BFB. So that's it about mean value theorem and its graphical representation. Let us see some examples to find out this exactly what does it mean. So here I have a question to verify the mean value theorem if f of x is equal to x cubed minus 5x square minus 3x in the interval AB, where a is equal to 1 and b is equal to 3. Given f of x is equal to x cubed minus 5x square minus 3x, where a is equal to minus 1 and b is equal to minus 3. To verify mean value theorem, the conditions, there are three conditions which must be verified or satisfied. And what are the three conditions? f of x is continuous in the closed interval 1, 3 and differentiable in open interval 1, 3, and f dash c should be equal to f of b minus f of a divided by b minus a. So here f of x is equal to x cubed minus 5x square minus 3x, polynomial function. So it should be continuous in the closed interval 1, 3. And also since it is a polynomial function, it should be differentiable in open interval 1, 3. Now according to the theorem, let us find what is f dash c. And to find out that, we have over here f of x is equal to x cubed minus 5x square minus 3x. And to find the value of f of 1, substituting x is equal to 1, you get it as 1 cubed minus 5 into 1 square minus 3 into 1, or that is nothing but 1 minus 5 minus 3, or it is f of a, which is equal to minus 7. To find the value of f of 3, substitute x is equal to 3, and you get f of 3 as 3 cubed minus 5 into 3 square minus 3 into 3. And finally, after doing all the calculation, you will be getting it as minus 27. According to the mean value theorem, f dash c is equal to f of b minus f of a divided by b minus a. So f dash c, what is f dash c from this given equation or given function? You get it as 3c square minus 10c minus 3. Now substitute all the values in the above formula, that is a equal to 1, b is equal to 3, f of a as minus 7, f of b as minus 27, and what do you get? 3c square minus 10c minus 3 is equal to minus 27 minus minus 7 divided by 3 minus 1. And you finally get it as 3c square minus 10c minus 3 is equal to minus 20 by 2. That is 3c square minus 10c minus 3 is equal to negative 10, or you get it as 3c square minus 10c minus 3 plus 10 is equal to 0, or 3c square minus 10c plus 7 is equal to 0. And you can factorize it, you can write it as 3c square minus 3c minus 7c plus 7, or you take it common, you get it as 3c into c minus 1 minus 7 into c minus 1, or finally 3c minus 7 into c minus 1 is equal to 0, or c is equal to 7 by 3, or c is equal to 1. In this, you can see that 7 by 3 is an element of what? 1, 3. So you can say this particular value of c is the one which satisfies the mean value theorem, all the three conditions of mean value theorem, that is differentiable, continuous, and also how to find f dash c, which is equal to f of b minus f of a divided by b minus a. If f defined from minus 5 comma 5 to r is a differentiable function, and if f of x does not vanish anywhere, then prove that f of minus 5 is not equal to f of 5. The given function f from minus 5 for all real numbers is a differentiable function. We know that every differentiable function is also another what? Continuous function. So the given function is continuous on closed interval minus 5 and differentiable on open interval minus 5 and f dash c should be equal to f of b minus f of a divided by b minus a. Therefore, according to the mean value theorem, there exists c which is between minus 5 and 5, and the value of a, that is minus 5, and b is what? 5. So f dash c is equal to f of 5 minus f of minus 5 divided by 5 minus minus 5. And you can also see that f dash c is equal to f of 5 minus f of minus 5 divided by 10. So you can see 10 f dash c is equal to f of 5 minus f of minus 5. And f dash x is not equal to 0, or 10 f dash c is not equal to 0. So from this I can say f of 5 minus f of minus 5 is not equal to 0, or f of 5 is not equal to f of minus 5. So that is how we proved that particular question. So now we have studied the different conditions for mean value theorem. Imagine a car which starts from its initial point and reaches its destination, which is in a different point. Does the mean value theorem get satisfied in this particular conditions? With the knowledge gained from this session, please try to do this question. And now let's have a quick recap of what all we have learned.
Manorama Horizon. Learning made simple.